Okay, so I'm recording this 2.8 notes. So we're gonna get about halfway through this today. We're gonna do a couple calculator problems. The first few though are no calculator. So the first 4 are no calculator. And I believe we've looked at this, I think in unit 1 or unit P, we did a little bit of this. I'm gonna treat it like we haven't talked about it ever, but it should kind of come back to you at least a little bit. We're looking at functions and we're determining when the function is positive, 0, and negative. So if it's positive, my f of x, my function, would be greater than 0. If it's actually 0, my function, f of x, would equal 0. And if it's negative, my function, f of x, would be less than 0. So I'm going to kind of refer back to this later on, but I wanted to kind of set us up for success. I will not always ask you to do all 3 of them. I will often ask you to just do 1 or 1 interval, but I want us to kind of look at all of them in this first one as we are learning and as we are first understanding it. And I'm just being a little crazy about color coordination because I want to keep this consistent through the whole lesson. Okay. So the first thing that matters when we're looking at whether the function is positive, 0, or negative is I care about the factor. So I need it in factored form. If it is not already in factored form, I need to put this into factored form. However, we lucked out. This first one is already factored, which is great. Factored means it's in the parentheses. It's as broken down as much as possible. So I first find what are the factors or what are the zeros. And that's going to tell me where my function is equal to 0. The zeros, the roots, the solutions, whatever word you want to use, that's where each factor is equal to 0. And you don't have to do this step with me. You can just watch. I'm just, being a little dramatic and proving a point. But I'm going to set each factor equal to 0. I'm going to set x plus 3 equal to 0. I'm going to set x squared plus 1 equal to 0. And I'm going to set x minus 4 squared equal to 0. Most of you can do these in your head, so I minus 3 from both sides, so one of my zeros is x equals negative 3. Cool. The next one, I'm going to minus 1. I get x squared equals negative 1. I square root, square root of negative 1 is I, so I've got plus or minus I. I can't graph I on my calculator, so I don't need that factor at all. He does not matter. He does not give me a 0 that I'm going to graph on my graph. And then the last one, this squared, I don't want to FOIL that out. I can just square root both sides and get x minus 4 equals 0, and then add 4 and I get x equals 4. Again, most of us can do this in our head, so you maybe didn't need to waste the space, but that means that my function equals 0 at these zeros. So at negative 3 and at 4, where my function is equal to 0. In order to find out where it's positive or negative, I'm going to use a number line, and then I'm going to use something called a sign chart. So I'm going to number line these zeros. Put it right here. The only place on this number line that matters are my zeros, because zeros are where something changes. Either at a 0, we either cross my axis and do something funny as we keep going, or we bounce and stay above or stay below that axis. So the 0 is where something happens. If you go on to take calculus, like we spend a lot of times looking at these like points of interest, and like a 0 is a point of interest because like something is happening there. As we look at these points of interest, I can't use the actual zeros because if I were to plug those into my equation to solve, I would get out 0, and that's not helpful. So I want some number in these intervals. So like in the interval from negative infinity to negative 3, I just need to pick one number to kind of like run a test through, essentially. So I like to pick kind of the smallest number I can, or the easiest number to work with. So I'm going to pick negative 4. That's somewhere in this interval right there. In the middle interval, something between there is 0. 0 is in between negative 3 and 4, and that's the easiest one to work with. So I always work with 0 if I can. And then last, between 4 to forever is 5. So I'm going to use 5. I'm going to make a sign chart. On my sign chart, I use all of the factors. So all of these factors up here go on the top of my sign chart. So I put x plus 3. I do x squared plus 1. I know he didn't give us a 0, but he's still part of the equation. And then I've got x minus 4 squared. The numbers that I just picked a minute ago get to go along my side because that's what I'm plugging in to try and figure out. I'm trying to find the signs of these. So I'm going to do -4, 0, and 5. Now, I don't care actually what comes up when I plug these in. I just care whether it's going to give me a negative or if it's going to give me a positive. So if I do -4 plus 3, that's going to give me a negative. -4 squared, well, that stays positive no matter what. And then anything squared is always positive. These numbers multiplied together, a negative, oh, I know that's not a good highlight. A negative times a positive, well, that's, the negative is reigning supreme there. So we're going to keep the negative there. If I were to multiply any negative times a positive number, I still get a negative number. All right, now we try 0. 0 plus 3 is positive. 0 squared is going to stay positive, and anything squared will be positive. So all three positives multiplied together keep it positive, and now I'm going to try 5. 5 plus 3 is positive. 5 squared plus 1 is positive, and then 5 minus 4 squared is also positive, so they stay positive. What this sign chart did is it's saying that no matter what x between -infinity and -3 I plug in, I'm going to get out a -y. Any x I plug in between -3 and +4, I'm going to get out a +y. And then any number I plug in between 4 and +infinity will be a +y. These are helpful. This number line is helpful because it's going to tell me what's greater than 0 and where my function is less than 0. So let's do greater than first. So greater than are where my plus signs are. So the interval between -3 and 4 and the interval between 4 and infinity are both where my function is greater than 0. However, do you see how it says greater than, not greater than, or equal to? Since it's not or equal to, I don't get to include 4 because 4 is equal to 0. If you plug 4 in, you get out 0. So I don't get to include 4. I'm going to do the intervals, -3 to 4, parentheses, because it's it's a greater than, not a greater than, or equal to. And then I'm going to do 4 to +infinity. Now I want to do my negative y's, where f of x is less than 0. So I'm going to go over here and find the negative interval, which is the only interval left. It's the one that I got the negative sign from, -infinity to -3. Any number in between there will give me a negative y or a negative f of x. So I'm going to write -infinity to -3. When I give us problems like this, our answers are the intervals. Now, you did not need to do all this work in red like I did. I just was, again, proving a point. But in order to get full credit, you need to show me a number line, you need to show me a sign chart, and then you need to do either all 3 of them or whichever one I asked for. Any immediate questions? If you're still like, I'm not 100% sure what's going on, hang tight for another 1 or 2 and maybe you'll pick it up. Anyone have any clarifying questions before I do that though? All right, we're gonna do another one. Exact same idea, except I don't have to find all 3. I don't have to find positive and 0 and negative. All I care about this one is it says solve, and it gives me a function and then less than or equal to 0. So all I care about here is I don't need to do all 3 of those. I just care about where f of x is less than or equal to 0. That is the interval I'm looking for. Okay. That being said, I still care about my 0. So I still want to list my zeros. I need my zeros in order to make a number line and in order to make a sign chart. So I do like to list my zeros. I'll do f of x equals 0, and those are -7, -4, and +6. I don't need to show my workout again. I don't need to prove that point again, but I just set each of these factors equal to 0. Now I use those to draw a number line. So I'm going to draw my number line over here. And the numbers on my number line are my zeros. So in this case, -7, -4, and 6 are all important. -7, -4, -6. Before I draw my sign chart, I'm going to figure out which numbers I want to kind of guess and check with. Again, there's no right number. As long as you pick a number between -infinity and -7, you are correct. I'm going to pick -8. In between -7 and -4, I'm going to pick -5. In between -4 and 6, I'm going to pick 0. Now, a lot of us want to forget about this last interval. That's a common thing I've seen with my pre-cal students in the past. So don't forget to also do this one. I'm going to do 7. Again, there's no right or wrong answer. That's just what I think is the easiest numbers of those sets. I'm going to do my little sign chart over here. My factors are x plus 7, x plus 4, x minus 6 squared. And then I'm trying -8, -5, 0, and 7. Any questions so far? The first thing we did is we looked at it was factored form, so that's good. So I identified the zeros. Once I identified the zeros, I made a number line, and then I used that number line to figure out what numbers I wanted to check in my sign chart. Now I'm going to complete my sign chart, and then that will help me determine my interval where f of x is less than or equal to 0. All right. I keep talking through this. This is just my inner monologue because I want you to start thinking about what you should be thinking about. I'm just plugging them in. And again, it doesn't matter what the number is. It just matters that what the sign is. So -8 plus 7 is going to be negative. -8 plus 4 is negative. And then this is squared. So anything squared is going to be positive. Negative times a negative times a positive. Ooh, that makes positive. -5. -5 plus 7 is positive. -5 plus 4, oh, that's negative. And then anything squared is positive. So that's going to stay negative. 0 plus 7 is positive. 0 plus 4 is positive. Anything squared is positive. Okay, that stays positive. And then last 7. 7 plus 7 is positive. 7 plus 4 is positive. Anything squared is positive. Okay, I've got another positive. The whole reason I found these is now I'm going to go put them on my number line. So the interval where -8 is, so anything between -infinity and -7 is going to give us a positive y. The interval where -5 is, wherever -7 and -4 is, will give us a negative y. The interval where 0 is at, between -4 and 6, any x in there will give us a positive y. And then any number bigger than 6 will also give us a positive y. All right, now I have all of the tools I need. I just need to read my number line in order to find out where f of x is less than or equal to 0. It's less than or equal to 0 wherever it's negative, so that's this interval. Now, it doesn't just say less than 0, it says less than or equal to, so I also have to include all the zeros that are equal to 0. So -7 and 4 are easy because they're already attached to my interval I was already looking at. I also, though, need to include 6 because 6 is a 0. 6 is a 0. It touches the x-axis. It counts as 0. There's no interval with 6 because everything around it is bigger than it. It's all positive. but I do have to include 6. So this is what my interval is going to look like. The first one's easy. We know that if we're including -7 through -4, we use brackets and we put a comma in between them. Since there's no interval with 6, we just put 6 by itself. Not in a parentheses, not in a bracket, not anything crazy. I guess technically you could use these little braces, but we are not in like advanced linear algebra, so I'm not doing that with you guys. If you want to major in math in college, you can do that then. And so that blue box is my answer. Any questions so far? I forgot to prove this point on the last problem, so I'll just do it on this problem. Let's graph this and look at what my graph is telling me, because I think sometimes looking at what the graph says helps you understand why this matters. Basically, this number line is just a very simplified version of what the graph looks like. So I'm pulling my graph up, or my calculator up, and I'm graphing this equation right here. So I'm gonna go to y equals and do parentheses x plus 7, parentheses x plus 4, and then parentheses x minus 6 squared. Ooh, got all this other stuff. I messed up. Yes, okay. Squared. Okay, that was messy. I'm so sorry. That was so weird. I should have just cleared it out, and I didn't. Anyway, I have this ready, so I'm going to go to my calculator. Ooh, my window's off. Let's just go to a standard window. I don't know why it was funny. Probably from last class. Cool. I can make my graph bigger to see the ends here, but all that really matters is my intervals. Let's, for sake of argument, we'll make our y's a little bit bigger, -20 to +20. I don't know if that's going to fit, but we'll try. Nope, still doesn't fit. That's okay. What we can see here is I still have my zeros at -7 and at -4 and at 6. If I remember, well, I don't know, sorry. I'm like changing my mind in my head like 3 times. I do want you to see it all because I don't need us to improvise all of this. Why is this? I did it with the other one last class. Okay, nope, this is what I want. This is good enough. What we see, if we look at our sign chart, I'll kind of move it over so you can see our number line again. What our number line is proving to us is it says, I have a positive from -infinity to 7. The positive means that I'm above the x-axis. So do you see how my line before -7 is above the x-axis? Same thing for between -7 and -4, it's all below the x-axis. I'm sorry, I didn't find all the peaks and valleys, but trust me, we all see it's below the x-axis between -7 and -4. Between -4 and 6, again, it's above the x-axis, so it's all up here where all my y's are positive. And then at 6, we hit the axis again, but we don't touch it, we bounce. We have this square here, which we know from earlier in chapter 2 that that's where we bounce our graph. So we bounce here and then we stay on the positive side. So all this is saying is it's just putting a simplified version of what the graph looks like over here. Positive y's, negative y's, positive y's again, bounce the axis, positive y's again. What we're doing is when we can't use our calculator, this is the way that we organize our thoughts and our knowledge so that we're able to look at these intervals. Okay. This was not the best graph to explain it with, but does anyone have any questions about the graph or the picture? Okay. All right. We have 2 more before we get to use a calculator. These both are not in factored form. So we have a couple options. first thing we want to try and do is we want to factor it. If we can factor it, we want to do that. So we want to factor them down. If we can't factor it, then we need to go back to what we learned in 2.4 and 2.5, where we do our P's and Q's, find the possible rational roots, synthetically divide, factor, all of that fun stuff. So we're gonna have to put a little bit of work like that into number 4, but number 3 is gonna be a pretty easy factor job. So I need to get it into the factored form where it's all of the parentheses, and then once it's there, then I can do all of my normal steps. So let's start by factoring. I'm gonna do my grouping. I can take out an x squared, and then I'm left with, please undo. Nope. X minus 4. And then the other one, I've got negative x plus 4. I can take out a negative 1 to get x minus 4 in there. With grouping, you combine what's on the outside together, and then we just have one of those x minus 4s follows us. Ooh, but keep going. And sometimes I write this on your quizzes and tests. Don't stop. We can keep going. We can factor this out. X plus 1, x minus 1, x minus 4. This is helpful because I needed it in factored form. So we're here in factored form. And once it's in factored form, I want to list what the zeros are because I need that for my number line. I need that for my sign chart. So my zeros, where f of x equals 0, are negative 1, positive 1, and positive 4. All right, that was like algebra 1, algebra 2. Use that to help us step up. Now we're ready for like the pre-cal step. So I've got my number line. I'm going to put negative 1, 1, and 4 on my number line. I'm going to do my sign chart. My sign chart, I'm not going back to the beginning. I'm going to this step right here where all my factors are already in factored form. So I'm doing x plus 1. I'm doing x minus 1. I'm going to do x minus 4. And what I haven't done yet, that I'm sure some of you are like, why hasn't she done this? I haven't picked my numbers that I'm going to try and plug in. There was no reason I waited. I just was setting other things up. So I'm going to try negative 2. I'm going to try 0. I'll try regular 2, and then I'll try 5. Again, these are just guesses. There's no rhyme or reason, except it just has to be in the interval. So sometimes it's the only whole number in the interval. Sometimes it's what I just think is going to be the easiest one to work. Whoa. Negative 2, 0, 2, and 5. Negative 2 plus 1 is negative, negative, negative. Okay, that stays negative. When I plug 0 in, I get positive. Oh, that's negative, that's negative. Oh, but 2 negatives and a positive stay positive. Plug 2 in, I get a positive, I get a positive, and I get a negative. So that's negative. And then plug 5 in, I get positive, positive, positive. Oh, so that's all positive. Let me write my signs on my picture. Negative, positive, negative, positive. I will tell you this is the most common way that it's done. A lot of time it alternates. It starts with one sign and then goes like the other sign all the way down. So this was minus to plus to minus to plus again. I did want to do a couple examples where there were 2 of the same signs at the end though, because that for sure happens. I've had students in the past who just try and take a shortcut, and a shortcut doesn't always work because that sometimes it alternates like this doesn't mean that the last one is also going to alternate. So make sure that you're careful and solve all the steps. Don't try and cut too many corners because you might not be able to get the right answer. Okay, we found our zeros, we did our number line, we did our sign chart, and now it says that we want where it's greater than 0. So all I want to do is where my function, f of x, is greater than 0. Well, looking at my number line, that's the intervals where it's positive. So here's a positive, so between negative 1 and 1, And then here's another positive, so between 4 to infinity. It says just greater than, so I'm going to use parentheses. I'm going to say -1, comma 1, and then 4, comma, oops, forgot a u, 4, comma, infinity. Again, my answers here are not the number line or the sign chart, but I need those in order to write my interval. So in order to get full question or full points on questions like this, where we don't get to use our calculator, you got to show me all these steps. Okay, now that we've done 3, are there any questions, anything that you're confused on or concerned with? Is it awful quiet today? That's all right. All right, we're going to keep rolling. I've got one more problem, and then I want to do 2 with a calculator before we leave. We do got to put some work in on number 4. I think I already previewed that, but this one doesn't factor nicely. I went to try and do grouping, and it didn't work. And this one doesn't say solve with a calculator, so we got to do this one by hand. In math, a lot of things build on themselves, so we have to go back to, was it 2-4 and 2-5, where we did our P's and Q's. And then once we did that, then we had to plug it in or use synthetic division to find out what the factors were, blah, 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 all that fun stuff. I know a lot of us are muted, but you might be at home being like, oh, come on, I thought we were over that. We're not, sorry. So this is my P, my constant, my number without any X's at the end is the P. And then the number at the front, the leading coefficient is my Q. So factors of 24, ooh, there's a lot. 1, 2, 3, 4, all go into 24. And then now we got to come back down. So 4 and 6, 3 and 8, 2, 12, and then 1 and 24. And then in the bottom, I've got 1 and 2. Okay, now remember that I don't need you, I'm not going to waste your time going all the way like to 8, because that's so much time in synthetic division that like I don't need to test. It's probably going to be in one of the first 2, 1 and 2, or positive, -1 or -2. If it's not, then I should give you a hint. And so I'm going to tell you we're going to try all of these, the first couple at least, to see what we get to. Now, I've also shown you where you can plug it in. And then once we plug in, we can do synthetic division. I've had some students, they'll be like, well, why don't we just do synthetic division from the beginning? That also works. So that's what I'm going to do here, just so we don't have to do a second step. So I'm going to set up my synthetic division. And then if it doesn't work, I'm just going to erase it and then try another number. So again, we're trying 1, -1, 2, -2, and then hopefully we find it by then. Got 2, 2 times 1 is 2, which is -5, which is -5, which is -15. Oh, 24, -15 will never be 0. Okay, reverse, reverse. All right, let's try -1 then. Whoa. So 2 times -1 is -2. That gives me -9, which gives me +9, which gives me 1. But 24 minus 1 is not 0, so that doesn't work. All right, let's try 2. 2 times 2 is 4, -3, which is -6, which is -32. 24 minus 32 is not 0. Oh, we're getting down to the wire. This is where I told you I'd give you a hint. So -2 better work. 2 times -2 is -4, which is -11. That becomes +22, which is +12. And then -2 times positive, oh, thank goodness, 0. Remember, when the remainder is 0, that's when I know it's a factor. So then I get to take 2x squared minus 11x plus 12 and either factor it or quadratic formula. A lot of us tend to quadratic formula, which is totally fine. Just sometimes I find myself writing on your homeworks or on your notes or excuse me, on your tests or quizzes, I find myself writing like, keep going, keep going. Like you'll leave it as a squared 25, or you'll make square root 25 5, but then you like don't simplify that fraction. Like you have to go all the way. This one I actually think factors nicely, so I'm gonna factor. I like to factor better anyway, so if I can factor, I like to do that. 2x and x, multiples, or sorry, factors of 12 are 1 and 12, 2 and 6, 3 and 4, 3 and 4 work. 4, 3, positive 12, so they're both negative. Negative 3 plus negative 8. Yep, that's negative 11. All right, so that gives me my factors, or my zeros are 3/2 and positive 4. And don't forget about negative 2. That's why I made a big deal during 2-4 and 2-5 that you wrote down all the factors. And if you forgot that one that we synthetically divided with, we would mess up this next step. So we got to include all of them. All right, the whole reason we get it in factored form is so that we can draw a number line. So let's go draw our number line. Negative 2, 3/2, and 4. Now for our sign chart, you can use the factors form that we just had right here, but also since we know the zeros, we can just write it like that, x minus the 0. So x minus negative 2 is x plus 2, x minus 3/2, x minus 4. There's no need to do anything too crazy or fancy here. All right, now we got to decide what numbers we're checking. I'm going to check negative 3, I'm going to check 0, I'm going to check 2, and I'm going to check 5. I'll zoom out a little bit so you can make sure you're caught up. I know I'm jumping around a lot. It was not in factored form, so I had to use my PRRs and my synthetic division and then factor in order to get my zeros. Then I put them on a number line, then I'm putting them in a sign chart. Now I'm checking for all the signs. Negative 3, 0, 2, and 5. Negative 3 plus 2 is negative. Negative 3 minus 3/2 is negative, and negative 3 minus 4 is negative. So 3 negatives stays negative. All right, 0 plus 2 is positive. 0 minus 3/2 is negative, and 0 minus 4 is negative. 2 negatives, oh, that does make a positive though. 2 plus 2 is positive. 2 minus 3/2 is positive. And then 2 minus, oh, that's negative. So that makes all of it negative. And then last 5 plus 2 is positive. 5 plus 5 minus 3/2 is positive. And then 5 minus 4 is positive. Nice. Now I need to put these on my graph. Negative, positive, negative, positive. And I care about where we are greater than 0. So I care about here and here. It's just greater than 0. So I'm going to say f of x is greater than 0. So I'm going to use my intervals, negative 2 to 3/2, and then 5 to 0. Oh shoot, not 5, sorry, 4. Well, actually, that's a good point. Let's talk about that. I did 5 because, and this is a common mistake I've seen from pre-cal kids, I wrote 5 because in my brain I was like, oh, I just was doing something with 5. I was just talking about 5, so I feel like I should use 5. Remember, that's not it. You need to use the zeros. You don't ever use one of the numbers you plug in. So sometimes I see people doing like 3 to 0 and then 2 to 5. These numbers were just helpful hints. They're not actually the answer. My actual answers are the zeros, negative 2, 3/2, and 4. That's what actually gets to be put in for my answer. Okay. I just wanted to tell you a common problem I see so then you don't have to make that mistake. I believe in life you shouldn't make all the mistakes. You got to learn from other people's mistakes. Any questions so far? Okay, let's do the last two. These two are calculator problems, so they're a little bit easier. I think we've got plenty of time to do them. When it says solve with a calculator, all we're doing is plugging it into the calculator and then finding our zeros there. So usually we do this when it doesn't factor nicely. So I don't need to do a sign chart and I don't need to do a number line here. I will probably sketch the graph just so I know what I'm looking at, but that's all. Before I plug this in the calculator though, move everything to one side. I like to bring everything to where the positive or the biggest exponent is, where the biggest exponent is. So I'm gonna minus 2 from both sides and I'm gonna add 8x to both sides. So I get x to the third minus 6x squared plus 8x minus 2 is less than or equal to 0. Okay, that's not hard. Let's go graph it. Scoot it over a little bit so we can still see it. So I'm gonna graph, not that. X to the third minus 6x squared plus 8x minus 2. Okay, that looks fine. All right, I think my window can just be normal. So I'll go to Z standard just in case my window was off. Oh, beautiful. All right, I've got this beautiful graph here. And again, the reason we did this is because my zeros aren't gonna be nice. I'm gonna actually draw a sketch of this graph on my paper because I'm gonna wanna draw on it in a second. It's a sketch, so it doesn't have to be perfect. Something like this. That's as good as I'm gonna get. I'm not an artist. So let's do this. We don't know what my zeros are. So let's go find it in my calculator because that's going to be helpful when I need to identify my interval because the zeros tell me where I start or where I stop. So second trace 0. Sorry, I'm just kind of speed doing zeros. If you don't know how to do zeros at this point, please let me know because I'm assuming you know how to do it. So I've got a 0 at 0.32. I got a 0 at, ooh, that's too far. 1.46. And I've got another 0 at 4.21. Okay, so now I want to draw my picture, which is why I drew it over here anyway. So there's my 3.2, here's my 4.21, and my 1.46 is that one. You could have labeled it better. I just trying to get through this, so I'm sorry it's not picture perfect. We want to know where this is less than or equal to 0. I care about then where it's below the x-axis. So I care about here, where it's below the x-axis, and I care about from here to here, where it's below the x-axis. The whole reason I needed my zeros is that helps me define my interval. So f of x is less than or equal to 0 at, well, from forever to that first 0, so from -infinity to 0.32. Notice that it's an or equal to, so I am gonna do a bracket here. You never bracket infinity, you only bracket numbers. And then I'm gonna do it from the second 0 to the third 0 because it's that interval underneath. So 1.46 comma 4.21, bracket on everything. So when we solve with a calculator, and I might even write this on the side, graph, and find zeros. So you don't need a sign chart, you don't need a number line, all we need is a graph on the calculator and the zeros, but my answer is still an interval notation. All of these answers are intervals. Okay, we've got just enough time to look at this last one, which is perfect. It says solve with the calculator. And it looks like two separate problems, but it's the same equation. Just one of them says where it's greater than 0. So that's when it's a positive y. And then the other one says when it's less than or equal to 0. So let's go graph this. I've got x squared plus 7, 2x squared plus 1. All right, cool. Hope my graph is good. Ooh. This is a good enough graph, but I do want to make my y max a little bit bigger so I can see more of it. So we'll go all the way up to 20. Oh, perfect. That's good enough. This graph is just a U shape above the axis. That makes sense. If we remember back to our rules on polynomial functions, I've got an x squared and an x squared. Well, that means it's an even graph and it's positive because there's no negative out front. So it's going to just be a U shape that's taking up just that part above the x-axis. Let me graph it just so we don't forget what it looks like. So if I'm looking at the interval where it's greater than 0, well, that's everything. It's never going to be less than 0. It's always going to be greater than 0. So for this, I'd write f of x is greater than 0 for all real numbers. Negative infinity to positive infinity. Everywhere we see that graph, it's positive. Any x value you plug in will give you a positive y. Now that being said, it's less than or equal to, well, there's nowhere down here where it's going to be negative. So that means that there's no solution. F of x is less than or equal to 0. It's a null set. It's an empty set. No solution. Nothing there. Okay, I hope I didn't rush too much at the end. Does anyone have any questions while my screen's still up? Okay, I'm going to stop my share of my screen, and I'm going to remind you that you're responsible for that 2-7 video and the homework that's due on Wednesday. I have not assigned 2-8. I will assign that next time we have class, and it will be due in 2 class periods from that. And then we're looking at a test on Tuesday. If you need anything, shoot me an email. You can hang out for a second. I'll be available for a few more minutes. And if not, good luck. Have a good rest of your day. I miss you. See you later.
Thank you.